So, good evening. Right. So, we'll be starting from where we left off. Last week. Sorry, can you close the window? So, basically, I will need to actually use the board. I don't know how this will not affect people at all. They can see my screen. Right, but we have to understand the basics of IP addressing. So, I don't know. Will they be able to see it? Not sure. They won't. How do you want to go about it? Like, I need to write, but people at home will not be able to see it. So basically, this is an example of an IP address, right? Like I said, so it's basically a unique identifier. Yes. So it's basically a unique identifier that's assigned to each device connected to a computer network. So we have classes of IP addressing. So we have classes of IP addressing. We have class A IP address. We have class B IP address. We have class C. We have class D. And we have class E. So basically, class A IP address starts from 1 to 126. That's the range of class A IP address, from 1 to 126. Then class B starts from 127 to 191. Class B starts from 127 to 191. And class C IP address starts from 192 to 223. 192 to 223. Then class D starts from 224 to 240. 224 to 240. So, and this class D basically is a broadcast address. Class D, that's 224 to 240. It's basically used for broadcast address. So the class of IP address that you'll be seeing, right, on the internet or that you'll be using is from class A to class C. Now, class D is basically used for broadcast. While class D is used for broadcast. While class E is reserved for an experiment. Class E is reserved for an experiment. So basically, IP address is divided into two, or we have two categories of an IP address. We have network and we have host. We have network addressing and we have host addressing. So basically, let me try to explain how they come about this 192.168.1.1. So basically, like I said the other time, that class C IP address starts from 191 to 224. So this type of IP address that we are seeing on the screen is class C. For you to determine if an IP address is class A, class B, class C, class D, or E, you will take the first octet. So in this case, the first octet is 192. And octet is 8, right? Mathematically, octet is 8. So basically, and we know that computer understand 1 and zeros, right? So basically, when we are talking about octets, we are talking about bunch of ones and zeros. So basically, let me see if I. So basically, it can be all ones, like it can be all ones, like 1 throughout the 8 bits, right? An octet is 8 bits, like I said. So that means this 182 has 8 bits, which is this 110000 and 6 zeros that follows. Don't worry, it's clear. I won't go that. I won't actually go deep like that. Just want to actually let you know some part of IP addressing that you will need for the exam. So basically, they come across this 192. So the 8 bits basically is from 128, 64, 32. I need to write, but I don't know. I don't know how I want to do it. So the 8 octets, right? If it's all ones, right? We can't understand by just actually like, so if I'm just saying it, you can't understand. That's the fact. That's the point. But how will I write? Okay, I will type it. Oh my God, it will take time. We've been trying to use it. They don't see it. That's the point. The whole screen now. I don't know. We should be able to write now. Okay, they can see it now. Showing. Yeah. So they should be able to see it. So basically, if this goes up X is all ones, let's say this is all ones. 1, 2. And we said this octet contains 8 bits. That's what makes it octet, right? So that 8 bits can be 0, 1, or throughout 0 or throughout 1. If it's 1 or 2, 1, 2, 3, 4, 5, 6, 7, 8. That's this an octet. 8 bits. So basically, starting from this, it is 128, 64, 32, 16, 8, 4, 2, 1. Everything like this, equation was 105. You add it all together. Sum it. 128 plus 64, 182, 224, 240, 248, 252, 254, 255. Everything is going to give us 255. Sum everything together. Right? Now in this case, okay, so this if it is 1, that means it's on beat. We call it on beat. Right? If it is 0, we call it off beat. Right? So that means those off beats, you won't count them. They are out of scope, you won't count them. So in this our case, these are 182 bits, right? If you had the first 128 plus the second 64, so basically if you have these first 2 bits together, Hmm? No, it's not for. So, like I was saying, since we can't write it down, so I will not waste our time. 510. So, if it is all ones, everything is going to give us 255, right? So, in this case, in 192 case, right, the first bit and the second bit was on, and every other bit were off, right? So basically, that means we are going to sum the 128 plus 64, right, to give us 192 in the first octet. That's how they arrived at that 192. So yeah, one. So basically, if you write this out again, right? Like I said, this first octet has 8 bits in it, right? So that is this first octet, right? It was explained, has 8 bits in it, right? So if it's all ones, right? If we are going to start from 128. From there, it's like this: 128, right? 64, 32, 16, 8, 4, 2, 1, right? So the maximum that can be in an octet is 255 that we can have in any of these octets. 255, right? So, but in this case, they give you 192. So that means this 192 is coming from, you trying to write all these ones out again, right? So basically, that means the 128 bit is on, right? So 128 bit is on plus 64 bits. Do you get? Like this, we take this one out, right? Like I said, everything, if it is all ones, if the first object is on, if everything is on, right? This 8, right? You will start starting from this level. You're 128, right? So from 128 to 64 to 32 to the last bit that we have here, right? So all of them contain in decimal. You write it in decimal format. Let me put it that way. You write it in decimal format. It's going to be 128. This first one is going to be 128. The second one is going to be 64, 32, and like that, right? But in this case, they give me 192. And I said the total sum that you have in an object is 255. We add all these ones together, it's going to be 255, right? So, but the big 192. So that means some bits are on and some bits are off, right? So in this case, 128 is on, right? If you write it like this, 128. So 128 so 128, right? 64, 32, 16, like that. If you write it like that. The ones are on and the zeros are off. So basically, that means we are going to add these two together. So it's going to be 128 plus 64 to give you this 192. Do we get that? So in this case now, this is 168, right? So basically, so 68, that means 128 will be on already, right? If you are going to add 64, it's going to be more than 168, right? It's going to be 192. But they are giving us, they give us 168. So that means the second bit is off. So plus 32, right? So plus 32. This is going to give us 160, right? Going to give us 160. So the next bit is off because the next bit is 16, right? We are going to add 16 to 168. That means we are going to get, I don't know, maybe 116, right? 176, right? Which is more than 168. So it's off. The next bit is on, which is 8. So that means 128 plus 32 plus 8 is going to give us 168. So that means the remaining bit in that object will be off. It's just binary to decimal, normal mathematics that we did in that. So basically, that's how it works. And basically, that means in this case, everything is off and the last one is on. And like that, in this case. Just know that this is called object. Right? It's called object. And it has 8 bits in it. You have a question? Okay. The second octet. And what do you represent like that? Yes. So basically, that's the rule. Anytime you see an IP address, we use the first octet to determine the class of IP address it is. So the remaining one. So basically, like I said, IP address is divided into two. We have network and we have host. So it's an IP address. So basically, class C IP address is talk about subnetting. We understand. So basically, we have to go into subnetting. We want to understand how to come across network and host. But basically, let's move on. We still talk about it. But we understand how we arrive at this. So basically, class A 1 to 127. So that means if this happens to fall between 1 and 127, it's class A IP address. This first object. So class B 128 to 191, 127. And class C is 192 to 23. So basically, this class of IP address will be seen on the internet. But basically, class D IP address is used for broadcast 224, 240. And class E starts from 240, 241, basically 255, so, or 254. So, and it's used for experiments. Six. Anyways. So basically, if you want to actually determine which one is network and which one is the host, so that's where we will now be talking about subnetting. So basically, subnetting, if it is class, we are talking about class A IP address, subnetting, right? So that means the first object will be on like this. Class A will be like this. The first object will be network, and the remaining will be host. We are talking about class A, just actually attribute this network host to the subnet. So basically, I will actually explain. Class B is going to be network, host, and class C going to be network, host. And in any of these class, anywhere you see the network, the bit in this all this octet is on. That means it is 255. All the bits are on. Anyway, we are talking about network side of the subnet mask. All the bits, right, that is the network side will be up, like they will be on. Everything will be on. So basically, that means the class A will be the subnet mask for class A is going to be 255, and the host is going to be 0. This class A subnet mask. This class B subnet mask. And this class C subnet mask. and we have class C broadcast. Everything is going to be 25555 like that. So basically, this is subnet mask. So the kind of subnet mask of this will be what? Of this class C will be what? Yeah. Okay, let me show you what I mean. Let me just open my terminal. So let me just show you the example of an IP address of this system. So if you do ipconfig /all, right? So basically, this is an example of my wireless IP address. This. What's that about Wi-Fi? Class what? Basically, class C. I said you will determine by cause of death. And one of the two falls under this. One is 223. Right? So basically, and this is 182. Right? So class C. You see the subnet mask. This is the subnet mask, right? It's 255.255.255.0. So don't worry, let me just let's lead everything out the way we normally do. Then if you have to write anything, then we'll come back again. So basically, if you ping this IP address now, my IP address is going to go. I think we used that utility the last time. The ping, can you remember? Okay. Use ping. So ping 182.168.0 dot what? 199. 192.168.1. That's the default gateway. Okay, that's the router IP address. So basically, it's just showing that okay, the default gateway is 4. That's what actually leads you to the internet. The default gateway, the router that is connecting you to the internet. That's what we call default gateway. If you can ping it, that means basically you can connect to the internet. But if your default gateway has a problem, that means you can't browse, more than within your local area network, your LAN. So let me clean this up and let's start reading. So internet protocols are currently deployed and used worldwide in 2 major versions, right? We have IPv4 and we have IPv6. That's the 2 types of IP addressing that we have. The version of IP addressing, IPv4 and IPv6. So basically, the 192 168 that we solved the other time is typical example of IPv4. That's an IPv4 that we all accustomed to. So IPv4 provides a 32-bit address space. The reason why it is 32-bit is this. Like I said, the first octet has 8 bits in it, right? The second octet too has 8 bits in it, make it 16, right? The third octet too has 8 bits in it, making 24. And the last octet too has 8 bits in it, making 32. Do we get that? So that's how they come across the 32-bit address space. So basically, which by the late 1980s was projected to be exhausted. Okay, this is the reason why they say it will be exhausted in 1980. Let me show you the reason why. So we do this 32, right? 32 bits. We need to raise to power 32. How many figures? This one is 32. Like 16 blocks. 2 raised to power 32. We can use calculator. Maybe 16 million. You have calculator. People at home, you can help me. 2 raised to power 32 is what? You will agree with me that we have more devices now. More devices that are using IP address. All the devices, IoTs, our laptop, our laptop, our tablets, our phones, iPhone, we have more than 4 billion devices on the internet now. Like we have now. Yes, now at least like a person can have like 5 gadgets in their house, just a single person. In Nigeria alone, I'm very sure we have like 4 billion gadgets. Talk less of other countries. And all those gadgets will have their own IP address in it. But then when they are actually coming up with this IP address, they don't know that our Jagaban are coming, that they are going to use all this IP addressing, So that's how they actually come up with another IP address, version 6. So basically, IPv6 was introduced in December 1995 and provides a 128-bit address space. So I don't think you'll be able to pronounce it. 2 to the power of that. You can't pronounce it. It's a lot. So that means basically you can't finish this version of IP addressing. There's no way you can finish it. Right? Okay, let's continue. You will actually get what I'm trying to say. IP hosts or devices associate an address with a unique logical address. That's what I said. All the devices we are seeing, all our phone, our laptops, our tablets, they have their own IP address, unique IP address, right? So an IPv4 address is expressed as 4 octets separated by dots. It's expressed as 4 octets separated by dots. For example, 216.12.146.140. This IP address falls under which class of IP addressing? Are you sure? It is C, because the first octet is 216, right? So each octet may have a value between 0 and 255. Do you understand that? They may have a value between 0 and 255. They cannot pass 255, right? So, however, 0 is the network itself, not a device on that network. And 255 is generally reserved for broadcast purpose. Broadcast is you are trying to reach everybody on that network. Then you can send a broadcast address, which is 255.255.255.255. Everything is 255. All the bits are on. All the ones are on in that 4 octets. So that means the first 255 is on, the second 255 is on, the third and the fourth. Like that. That's broadcast address. So each address is subdivided into 2 parts. Like I said, we have the network number and the host. So if you are using a subnet mask of /8, if you have an IP address like this, you have an IP address like this. 10 dots, 10.2.1/8. This is what? Class what? Class A. And we are using 8 because the subnet mask is 255.0.0.0. Don't forget, the subnet mask for class A is 255.0.0.0. And for class B, it's going to be /16 for class B. Because the 2 octets are on, right? It's going to be 255.255.0.0, right? And class C is going to be /24, which is 255.255.255.0. So basically, we'll be saying an IP address written, 216.12.146.140 you can say /8, you can say /16/24. Basically, they are telling you that that's the subnet mask you are going to use by default, or it can be changed. But by default, that's the subnet mask that you are going to actually relate to that IP address. Basically, the subnet mask is actually identifying the network. So that means this 8/8, the first octet is the network, and the remaining ones are the hosts. So for class B, okay, fine. We don't need to actually go that deep. Let's just stop here. Okay. VPN. No, VPN doesn't change IP address. You will assign IP address to VPN, a private IP address to VPN. Mm. And that's it will change the location and assign an IP address to that location. Yes. They won't see your device IP address. They will see that IP address that is assigned to you by that organization that comes up with that VPN. You get? So basically, VPN, there are some companies that are in charge, right? That will give you that service. So those companies, they have their list of IP addresses. So immediately you connect to their VPN, they are going to assign an IP address to you that is different from the one you are using. So as to mask you or to masquerade you from the internet. So basically, you'll be using their own IP address, but not your own. That's actually. Yes, it is private to them. It's not general, it's not public. They are the owner of the IP address. A device on the internet. So basically, they are not going to see your own device in this case. Mm. See, there are something called proxy, right? There's something called proxy. Maybe we talk about that later because that's not the class. So basically, it's not like even if they are tracing the IP address, they are not going to trace it to their own device self. It's like there's another device in between you, them. So it's standing in between. So basically, they can decide to be changing the IP address to be assigning IP address to that proxy. So basically, when they are trying to even identify, they are not going to identify it to their company, not your own device too. Yeah, there is a lot of ways to actually do that. So where are we? So the network number assigned by an external organization, such as the Internet Corporation for Assigned Names and Number. This ICANN, they assign an IP address to devices. So it represents the organization's network. The host represents the network interface within the network. Like I said, your devices, your laptop, they are hosts connected to that wireless, to this gateway, right? So basically, all your devices are hosts. This guy is your network, your default gateway. So to ease network administration, that means network admin. Networks are typically divided into subnets, like I said, because subnets cannot be distinguished with the addressing scheme discussed so far. A separate mechanism, the subnet mask, is used to define the part of the address used for the subnet. So using subnet masks, that's when you identify the network and the host. They will give you they can give you any IP address. Without subnet, they are not going to identify which octet of this IP address is network and which one is the host. But when you see the subnet mask / anything, you will know that, okay, fine, which is /16. So that means the first 2 octets is the network and the last 2 octets is the host. So the mask is usually converted to decimal notation like this. Basically, this is /what? This 255.255.255.0 is /what? Yeah, it is /24. The first octet is on, which is 8. The second one is 8. The third one is 8, making 24. And the last octet is off. So I don't want it to actually look boring. That's why I'm trying. I don't want to actually go deep. We can go deeper, but we can't treat it like that. Yes, they do sell it. Yes, yes, they will. When they try to their own life, they don't have choice. So yes, because they know your own IP address, right? The VPN company, they know your own IP address. It is just the word that doesn't know. Because immediately you connect to their own VPN, they have your own IP address. So if you steal or you rob someone or you rob bank, and they are threatening the VPN company that they are going to shut them down. No, don't worry. Say this guy, we have his IP address. But Not all organizations, not all VPN companies will do that. If you pay for that VPN, which is not free, which is paid, and they review your IP address, and you know that they review your IP address, you can sue them. Yes, you can sue them because they must not disclose your IP address since you've paid. But if it is free, like if it is free, even those people say that they have your own IP address, they can actually use it for something else. Okay. So with the ever increasing number of computers and network devices, IPv4 does not provide enough addressing or addresses for our needs, right? To overcome this shortcoming, IPv4 was subdivided into public and private address ranges. Public addresses are limited with IPv4. However, private addresses can be shared by anyone, and it is highly likely that everyone on your street is using the same address key. You are using private IP address. It is unique to you. It will not be found on the internet, right? If you are using private IP address, immediately you want to go on the internet, right? So there will be like a router or a server somewhere that will convert that your private IP address to public IP address. Then I just go deeper so that I see people are sleeping already. So basically, the nature of the addressing scheme established by IPv4 meant that network designer had to start thinking in terms of IP address you use. IPv4 facilitated this in several ways, such as creation of private address groups. This allowed every LAN in every SOHO, which is small office, home office, like using one small router, basically for your house or for your small office. Situation to use address such as 192.168.2 because it is private, right? Basically, this table shows the private IPv4 addresses available for anyone to use. They are private and they can be assigned for everyone, anybody to use, actually. If you see 10.0.0.0 to 10.255.255.254, they are private IP addresses. And you hardly see them on the internet. They are private. So 172.16.0.0 to 172.31.255.254 is another private IP address for class B, right? 10 dots to 10 dots is basically class A. That's a private IP address for class A. That's the private IP address for class B. And 192.168.0.0 to 192.168.255.254 is basically private IP address for class C. They are private. They cannot be found on the internet. Do we get that? So the first octet of 127 is reserved for computer loopback address. So basically, loopback address is also called localhost, like my system. It's assigned to every device. Basically, this 127.0.0.1 is called loopback. If you ping it, you are pinging your system. Let me show you. If you ping this guy, you are pinging your device, basically. So basically, it is used for troubleshooting. Okay, I think you mentioned it. So the loopback address is used to provide a mechanism for self-diagnosis and troubleshooting at the machine level. If you want to check if your computer is up and running, so you can use it to actually check your computer. It's not public, it's not private, but it's assigned to every device interface. Just check if your computer is good to go. So it is called loopback or local host. So the loopback address is used, okay. So the mechanism allows a network administrator. Okay. So this mechanism allows network admin to treat a local machine as if it were a remote machine and ping the network interface to establish whether it is operational. To check if your computer is okay or is at fault. So we use the loopback IP address, which is 127.0.0.1. So IPv6 is a modern of IPv4. So which addressed several weaknesses in the IPv4 environment. So basically they are saying a much larger address field, which is IPv6 addresses, are 128 bits. IPv4 is how many bits? Sorry, again. 32. Yeah, 32. And IPv6 is 128 bits. So which supports 2 to the power of 128, like we saw the other time. So basically, it's going to give us 340, 282, 366, 920, let me share. So 2 to the power of 128 is going to give us that number. You can see. If anybody can just pronounce it, I'm going to give that person out. Read that number out. If you can read the number out. 340. Like you pronounce it normally. 340 what? Million K. You see how many commas? How many commas? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, or 14. So basically, that's the number of IP addressing that we have in IPv6. So basically, it ensures that address will not run out. That's IPv6. You cannot finish using this kind of IP address. What devices do you want to use? What is it? It's common. It's not common, but it is attached to all the devices now. Because it is complex. It is complex for people to actually solve. So IPv4 is common. IPv6 is not that common, but it is attached to all the devices now. You see the example of IPv6, and you see how complex it is as compared to IPv4. So basically, IPv6 also improves security, and it also improves quality of service, QoS. Basically, quality of service, we help services obtain an appropriate share of the network bandwidth. Like if what do they call them? ISPs. Sorry, if an ISP is saying they are going to give you 24 Mbps bandwidth, right? So probably QoS is going to actually confirm that for you. That's okay, fine. You are running that amount of 24 Mbps. So an IPv6 address is shown as 8 group of 4 bits. We know that IPv4 is actually 4 group of 4 bits, right? Like 1, dot, 1 dot, 1 dot, so like 4 different octets. But in this case, it's 8. In case of IPv6, 8 groups of 4 digits. But in IPv4, it is 4 groups of 4 digits, of 8 digits, I mean. So instead of numeric 0 to 9 digits like IPv4, IPv6 address uses the hexadecimal range from 000 to all Fs. Basically, hexadecimal is what? 16, right? So basically, that means it's going to span from 16, from 0 to 9, which is decimal. So basically, it's going to span from 0 to 9, then A, B, C, D, E, F. So the 10 will be A, 11 will be B, 12 will be C, 13 will be D, 14 will be E, and 15 will be F for hexadecimal, right? For hexadecimal. From 0 to 9, then A, B, C, D, E, F to make it 16. So IPv6 address use the hexadecimal range 0000 through FFFF and are separated by colons. In this case, not dots. They are separated by colons rather than periods. An example of IPv6 address is this: 2001 colon 0db8 colon 000 colon 0000 colon FFFF colon 0000 colon 0001. Now imagine you want to memorize like 10 of these IPv6 addresses. You can see it is complex and difficult to even memorize. Right. So let's move on. So to make it easier for humans to read and type, it can be shortened by removing the leading zeros at the beginning of each field and substituting 2 colons. Basically, if you have something like this, right? You can represent this with double colon, but they are leading zeros. To shorten it, basically, they are saying to shorten it. The leading zeros, you can represent them with double colons. So for the longest consecutive 0 fields, so all fields must retain at least 1 digit. They will now be 2 colons. So you will see it now. All fields must retain at least 1 digit after shortening. The example address above is rendered as, you can see, we have what leading zeros here has been removed to shorten it. So we have D8, right? And basically, the zeros, the 3 consecutive zeros, has been replaced with double colon, right? And the 4 Fs are still there. But for the last octet, the leading zeros has been removed and 1 is left behind because you cannot throw the 1 away. So after shortening, okay, we've seen it. So as in IPv4, there are some addresses and ranges that are reserved for special uses, like we said the other time. So we can actually see, right? So we have to extend it. No, we should move on, right? So basically, as in IPv4, there are some addresses and ranges that are reserved for special uses. In this instance, double colon 1 is the local loopback address used the same as 127.0.0.1 in IPv4. You know, we said the loopback address or the local host in IPv4 is 127.0.0.0 for troubleshooting, if you can remember, right? But the loopback address, the equivalent, IP address for IPv6 is :1 in IPv6. So basically, if you want to ping it in our terminal, it's going to be : where is this colon? :1 ping. So basically, it's the same thing as using 127.0.0.1. It's just, this is just the IPv6 version of that. So the range 2001 -DB8 : to this, right, is reserved for documentation use, as in the example above. So, and the last one are address that is reserved for internal network use and are not routable on the internet. Can't find them on the internet. They are for local, hosts or devices. So let's talk about Wi-Fi or wireless fidelity. So Wi-Fi. So wireless network, Wi-Fi, or the full meaning is wireless fidelity. So it's a popular method of connecting corporate and home systems because of the ease of deployment and relatively low cost, right? You don't need to run wires. You don't need, physical things. Just plug your MiFi to the wall socket and receive your service, right? So that makes it, come with a very low cost. So it has made networking more versatile than ever. Workstations and portable systems are no longer tied to a cable, right? But can roam freely within the signal range of the deployed wireless access point. So we have a range that this wireless can go. Maybe you cannot find this. Immediately you adapt it again, right? That's one of the disadvantages of Wi-Fi. Anyways. So however, with this freedom comes additional vulnerabilities to your network. So Wi-Fi range generally accommodates most homes or small offices. Range extender or multiple access points may be placed strategically to extend the signal for larger areas, such as a collegiate campus. The Wi-Fi standard has evolved since inception. Typically, each iteration offers more throughput at faster speed. To exploit a LAN, now you want to hack a LAN, right? To exploit a LAN, threat actors need to enter the physical space. That's before we have Wi-Fi. If you want to actually exploit a LAN, you want to hack a LAN before Wi-Fi, threat actor needs to enter the physical space. You need to go into that organization, enter their data center, right? Or immediate vicinity of the physical network, such as open ports. So immediately you enter their data center, then you can now plug your cable to the router or to the switch, to the port of that router or that switch to connect to your system before wireless or before Wi-Fi. At wall outlets or on a network device, for example, given physical access, threat actor may place sniffer tabs onto cables or plug in rogue USB device. So if you are sniffing a device, like I said, that means we are reading the packet that is being sent from one user to another, right? To actually derive some sensitive information from it. So by contrast, wireless media offers threat actors opportunity which do not require circumventing physical access controls. They don't need to even come to your organization. Again, since we have wireless, they can just stand out there and try to sniff your network from outside your compound, right? That's the vulnerability that comes with Wi-Fi. But prior to this time, that attacker or that hacker will need to come into your organization and try to plug his system to your router or switch or server or anything they want to hack. But now, Wi-Fi has made it easier for them. They can just connect to your network from anywhere, maybe outside your organization. At least if the range of that your Wi-Fi can reach where they are, they can hack you using your Wi-Fi, right? So for example, okay, exploitation of Wi-Fi weakness can occur from outside the parameter of physical access control by capitalizing on technological weakness or misconfigurations, right? So basically, this is how it works. This is your wireless access point that is feeding the laptop. So imagine that one of the laptops, right, is an attacker laptop. So we just connect like normal stuff to your network, and they can actually sniff your network or try to steal sensitive information in that network. Because they don't need wire, and nobody is even going to know that they are there trying to steal sensitive information because it's just Wi-Fi and they are connecting to that Wi-Fi. So let's check the security of the network. TCP/IP vulnerability are numerous, or transfer control protocol / internet protocol IPs. Vulnerability are numerous. Improperly implemented TCP/IP stack in various operating systems are vulnerable to various attacks. So basically, these are examples of attack that we can have on our network. We have a denial of service attack, whereby the authorized users will be denied access. They won't actually allow them to get access to the information they have rights to actually access. They will shut down the network, right? We have distributed denial of service. That one is actually relating to DOS, but in this case, they are using botnets, like a lot of compromised systems. Probably, maybe your system, your phones, has been hacked by someone, and they want to perform this type of denial of service attack. Basically, your phones, your system that has been hacked in their own server is called zombie, like they are moving. So they will be using your system to hack companies. They will hack your system, right? Just the way we are now. They will hack your system. And when they hack your system, maybe they hack all of our systems, say 10 systems, and they want to actually attack a bank or something. They will not use their own device. They will use your devices. So when police is coming down, they are going to catch you. So basically, that's how DDoS works, right? They are using zombies of devices that has been hacked. But they will tell you that don't click any link, you click. And basically, maybe you will not see anything actually occurring in your system now. But don't worry, somebody are using your system. Sometimes you just see your system being out, or it will come up, come down. We see blue screen. Basically they are using your system. They are using your system to actually perform some actions. Yes. So there are a lot of systems that have been hacked by that on the internet. But people that use that system, they will not know. But when all those hackers want to use it, they will just wake them up. When they want to use it, and they are going to use that system to attack the service they want to attack. So another attacks that we have is fragments. We have oversized packets, whereby they will send, if a server can actually receive, say, 32 bits of request, they will try to send like 168 bits so that that system can crash. It won't be able to actually take that service, and they can hack that system like that. We have spoofing, whereby we try to use someone else's IP address to hack, maybe to hack that same person or to hack another people on that in that organization. And we have man in the middle, whereby someone will sit in between two communication and start sniffing your message. If you are transferring money, they will just steal your money. So TCP/IP, as well as most protocols, is also subject to passive attack via monitoring or sniffing. Network monitoring or sniffing is the act of monitoring traffic pattern to obtain information about the network. They want to know what you guys are communicating. Maybe they can see one vital or sensitive information they can use, right? So observe the simplified network diagram. Think about the various types of network traffic: web browsing, email, authentication, and alerts traversing the PC information system highway. That is an organization network. Imagine if a threat actor was able to observe the traffic at various points on the diagram. What type of information might an adversary glean or derived? So basically, a threat actor is able to filter all the network that is being sent, all the packets that is being sent on this network. So imagine we are trying to actually send money to your manager, and your manager is down here. The manager is down here. Or say this is your manager's, an attacker is here, sniffing the network. So that means an attacker can just change the account details and put his own. So we have various network attacks. So basically, we've mentioned them, part of them. The first one is denial of service or distributed denial of service attack. So this prevents unauthorized access to resource or the delaying of time critical operation. So time to critical may be milliseconds or it may be hours, depending upon the service provider. Then fragment attacks. In a fragment attack, an attacker fragments traffic in such a way that the system is unable to put data packets back together. So instead of the packet to actually arrive and be complete, they won't be able. Maybe it will be very slow, and on the long run, the service will just crash. Then we have oversized packets attack, like we discussed. We have spoofing, faking the sending address of the transmission to gain illegal entry into a secure system. Then we have man in the middle, an attack where adversaries position themselves in between the user and the system so that they can intercept and alter data traveling between them. Then we have ports and protocols, or probably you can call them applications or services. So on a network, there are physical ports that you can connect wires to, right? So let me see this wireless. So this is what we call port network. So instead of using wireless, basically you can connect wire. We call it LAN cable. So you can connect LAN cable to just browse directly instead of using wireless. So on a network, there are physical ports that you can connect wire to, like the one I showed. So you can connect your wire to that place to receive the service. And we have logical ports. They are not wired, but they are assigned a number to them that determine where the data or traffic goes. So these physical ports. So physical ports are the ports on the routers, like this one, switches, servers, computer, etc. We have ports in our computers as well, to which you connect wire, e.g. your fiber optic cables or category 5 cables or Cat 5 cables. There are type of wire that you can connect to the ports, right, to create a network. As we can see, all those lines are wires connected to ports. So let's talk about logical ports. So that one is physical port. We can see it, then we can connect wire to it. But logical ports, when a communication connection is established between two systems, it is done using ports. You know, you just connect to your email and you start browsing, or you start sending message to another person without connecting wire to that person, right? Like we send chats without connecting wire to the other people. So basically, we are using a logical port. So when a communication connection is established between two systems, it is done using ports, right? So a logical port, also called a socket, you can call it a socket, is little more than an address number that both ends of the communication link agree to use when transferring data. Before you transfer, maybe you want to use HTTPS, you know, that one we agree to use that HTTPS to connect logically without wire. So basically, if you are using port 2, the other end too must use port 2. Because if you are using port 2 and the other end is using port 3, that means you cannot communicate. So if you are using port 2, the other end or the remote host 2 must agree to that port 2 so as to communicate, to establish communication. Do we get it? Or do I have to explain? We get this one. Port allows a single IP address to be able to support multiple simultaneous communication, each using a different port number. In the application layer of the TCP/IP model, I think we talked about TCP/IP model the last time, where we talked about layer 1, layer 2, layer 3, right? 7 layers. Yeah, where is that layer? Yes. So in the application layer of the TCP/IP model, which includes the session, presentation, and application layer of the OSI model, resides numerous application or service-specific protocols. Data types are mapped using port numbers associated with services. For example, web traffic or HTTP. At least we know HTTP or HTTPS. So this is the port number. It's port 80. But the secure version of HTTP is HTTPS. And the port number is 443. So that means if we want to communicate using HTTPS, secure version, the other end too must agree to that. We are using a secure version, and the other end can negotiate between HTTP and HTTPS. An attacker can hack the person because HTTP is not secure. It is easily hackable because everything you are doing is in plain text. It's not encrypted. So basically, if you are communicating using port 443, the other end too must use port 443. So table 5.4 highlights some of these protocols, and they are customary or assigned ports. When in doubt, systems should be implemented using the most secure version of the protocol and its services. So these are the numbers of protocols that we have. A well-known protocol or ports is from 0 to 1023. Now, those are well-known protocols. And the register port is from 1024 to 49151. Those are the register ports. We don't need them now. So, and we have dynamic or private ports. They are from 49152 to 65535. Maybe you should write them down first. When I'm asking questions, there is no forgotten. So we have secure ports, right? We've talked about those that are not secure, right? So let's discuss about the secure ones. So some network protocol transmits information in plain text. That means everything they are sending, you can see it. If you hack them, they are, where everything, the communication, you can see it. So it's in plain text or clear text, just like normal English. But it shouldn't be. It should be encrypted so that the third party will not understand what you guys are communicating. Meaning it is not encrypted and should not be used. Clear text information is subject to network sniffing. So if an attacker is able to sniff your network, they can see all the communication in plain text, unencrypted. So that means it doesn't have to actually decrypt anything, any code. You will just see everything you are communicating in plain text, normal English. This tactic uses software to inspect packets of data as they travel across the network and extract text such as usernames and passwords. So even if they hack into your system, when your username and passwords are in plain text, they will just see it. Sally, Sally. And it shouldn't be Sally, Sally. It should be, rubbish. It should be zero hash star hyphen, something that they will not be able to actually understand, even if they see it. But if you are using plain text or clear text, it will all be plain. You will see it. So network sniffing could also review the contents of the documents and other files if they are sent via insecure protocols. So basically, they are saying every time you are trying to communicate on the internet or you are trying to browse on the internet, try to use a secure version of the protocols or the port number that you want to use. So basically, these are insecure ports that we have. So file transfer protocol is in port 21, which is insecure. So that means it's sending files in plain text. The secure version is 22, SFTP. It's called Secure File Transfer Protocol. I'm not going to actually go through all of them one after the other. When the document is sent to the group, you can go through it. So we have Telnet. Telnet is like you are trying to connect to a remote network. It's insecure because everything you are trying to communicate to be in plain text. And we have Secure Shell, which is the secure version of the Telnet. It's in port 22. And it continues like that and like that and like that. So basically, these are the explanation of what they actually stands for. So file transfer protocol is basically used to transfer files, like I said. So simple mail transfer protocol. So it's the default unencrypted port for sending email messages. That's the function of SMTP, to send email messages, but it is insecure. The secure version is transport layer security, TLS, which will encrypt all the email that you are sending from the client to the recipient. We have time protocol. Basically, network time protocol or time protocol, we make sure that your time is correct, right? So time protocol may be used by legacy equipment or old version equipment and has mostly been replaced by using ports 123 for NTP. So NTP on port 123 offers between error handling capabilities, which reduces the likelihood of unexpected errors. Basically, like I said, NTP is used to synchronize time to make sure that your time is correct on anywhere you are using it. We have DNS, domain name service. So we have HTTP, like we discussed, is insecure version of HTTPS. Because when we browse now, we are using HTTP, hypertext transfer protocol. So and like that and like that. So when the file is sent to the group, you can go through it. Or normally that's what they are used for. So this is 3 ways handshake. Right? I think we discussed this. So this is TCP client or the host, and you are trying to communicate with the server, right? So the first thing you are going to send is SYN or synchronization. So basically it's saying, Alpha guy, are you up? It's communicating to that server. Hello, what's up? Are you there? And if the server is up, server will return SYN ACK or synchronization / acknowledgement message that I'm up. What do you want? Then the guy will be like, okay, fine, let's communicate. Let's send data then with acknowledgement. That's called 3-way handshake. That's how we communicate between client and server. you will communicate to the server that, okay, fine, is the server up and running? If it is up and running, it will return send ACK message to you that I'm up and running. Just to acknowledge, to send you your SIN, your end will help you there with an acknowledgement that, okay, I'm up and running. Then this guy will be like, okay, I confirm. Then let's the connection be established. Let's connect. So basically, between the client and the server, there is a system for synchronizing and acknowledging any request. It is known as three-way handshake. This handshake is used to establish a TCP connection between two devices. To establish communication on the web server, the client sends SYN or synchronization packets to the web server, port 80 or port 443. Like we said, port 80 is insecure version of 443. Port 80 is HTTP, and port 443 is HTTPS. So this is a request to establish a connection, like I said. So the web server replies to the SYN packet with an acknowledgement known as SYN ACK. Finally, the client acknowledges the connection with an acknowledgement or ACK. So at this point, the basic connection is established, and the client and the host will further negotiate secure communication over that connection. I think we should stop here today. 6:24. You think networking is boring? This is the networking part of your CC. Then tomorrow we'll be talking about cyber threats and attack. Then we'll be talking about type of threats. We have spoofing, we have phishing, we have denial of service. Then we'll be talking about them tomorrow, by God's grace. Then ransomware, all of this. Or you want us to finish it too? Then we use a tool called Zenmap tomorrow. Okay, we'll talk more about it. I mean, you don't want to go up. We should finish it. So basically, the networking part of CC is kind of boring to people, because they don't have any idea of networking, basic IP addressing. And my networking students, they don't even call. They understand everything. And I don't want to actually, just throw some bunch of terms that you will not understand to you as well. So basically, I think we should be able to actually flow when we'll be discussing this tomorrow. You should understand. But you need IP address in anything you want to do in IT. In IT generally, you will need IP address. And the basic I just taught you, at least, that should be suffice for you. In anywhere you are saying IP address. We cannot do as a human being without IP address. If you see IP address, your phone has IP address. Right? So if you go to Google, if you do what's my IP address, Google will show you your IP address. Right? If I do what is my IP address, so this is my public IP address that I'm using on the internet. Not private, public IP address of my system. So basically, you see that we are not secure on the internet. And they can actually use this IP address to track me by doing any nonsense online. That's why people are using VPN, so as not to get caught. So basically, if you want to go to dark web, dark web now. You can't even access dark web. You will use special browser. You use special IP address. You even use special identity to access dark web. And for you to even access that web, they will give you a task. Maybe they will say you should kill somebody or you should do stuff. Yes. It's not, they call it dark side of the internet. But if you go there, you can actually see a lot of things. It's like you are joining an Illuminati. Right. So if you go there, you will see a lot of hackers that can even teach you how to hack. But before you even have access to that platform, we go through a lot, and you must have something to offer as well. But to even admit to, they will say, even they can say you should eat stick, and you'll be recording yourself. After that, then you send it to that platform. So if you want to go to that web, don't worry, it's free. So we continue from here tomorrow. God's grace. Yes, ma'am.